Welcome back, deep divers. Today we're gonna dive into the life of a guy named Thomas Midgley Jr.
Oh, yeah, he's a
He's been called a genius, and
a one-man environmental disaster.
yeah. So is he a villain or just a victim of his time? We've got some articles here
Yeah.
from BBC News Mundo, the New York
Yeah.
Times,
Okay.
The Nation, and some bioinfo to help us figure all that out.
Most people haven't even heard of this guy.
I know, right?
But his inventions, well, they had a huge effect on the planet.
Yeah, for better and worse.
In the 20th century.
Yeah.
Huge impact.
We're talking about leaded gasoline
Yeah.
and Freon,
Two big inventions.
with some really massive unintended consequences.
Yeah.
So rewind back to the beginning.
Okay.
Midgley comes from a family of inventors.
Really?
Yeah, his grandpa even had patents for like better saws.
Huh.
So maybe invention was in his blood.
Seems like it.
He studied engineering at Cornell and pretty early on
Uh-huh.
came up with this really clever rubber ball hydrometer.
You know, it just shows how good he was at solving problems even way back then.
Yeah.
This hydrometer helped figure out the alcohol content in a car's cooling system, which was really important back then, to keep it from freezing up.
Oh, that's pretty cool.
Yeah.
Fast forward to World War I.
Okay.
Midgley's working on like synthetic fuel for airplanes, and he makes this big discovery.
Oh.
Yeah, he figures out that it's not just the physical stuff, but the way the molecules are put together, the structure, that's what makes it resist knocking in an engine.
Wow.
Big aha moment there.
A total game changer when it comes to understanding how things burn, combustion.
Right.
And on top of that, there's this crazy story about him.
Oh, yeah.
Yeah, he gets metal in his eye
Oh,
from a hydrogen tank explosion.
ouch.
And you want to know what he did? He used mercury to get it out. Talk about a dedicated scientist.
That's wild.
Yeah.
But speaking of dedication
Yeah.
and controversy,
Yeah.
let's talk about leaded gasoline. Engine knock was a big headache for the car companies back then,
Yeah.
and Midgley wanted to fix it.
The auto industry was booming. Everybody wanted a more powerful engine.
Right?
But the engines were making this horrible knocking sound,
Oh, yeah.
which made them less efficient.
Mm-hmm.
So he tests thousands of compounds
Wow.
before landing on tetraethyl lead, or TL.
And this is where things get a little, well,
Controversial.
yeah, I mean, he holds this press conference
Okay.
and pours T-Tel all over his hands
What?
and then inhales it to show everyone how safe it is.
Knowing what we know now about lead, it's
Yeah.
pretty shocking, Lead, it acts like calcium in your body.
Oh, wow.
Gets absorbed into your bones.
Uh-huh.
Messes with brain development, especially in kids.
That's awful.
They downplayed the dangers, even called it ethyl to hide the lead, which is
Yeah, that's pretty messed up.
disturbing.
The whole industry just pushed back on all the concerns, too.
Yeah, like with ethanol, we know it works.
Yeah.
But you can't patent it and control it.
Yeah.
It's not like leaded gasoline.
They chose profit over people's health.
Yeah, seems that way.
There were signs early on,
Like what?
deaths at the production plants,
No way.
workers hallucinating from lead poisoning.
You'd think that would have made them starve.
You'd think so, right?
Yeah.
But they just shifted the focus to safety in the factories.
Oh, so they ignored the long-term effects?
Yeah, the emissions from the gasoline.
They dealt with the immediate problems,
Uh-huh.
not the silent danger of lead in the environment.
And then there's this doctor, Dr. Robert Kehoe,
Uh-huh.
who was a consultant for the company making TL.
Oh, so he's got a conflict of interest there.
Yeah, he spent decades promoting it and doing research.
Funded by the industry.
Right, to downplay the dangers.
It makes you wonder who you can trust.
I know, right?
It shows how corporations can influence science.
Yeah.
The need for profit really overshadowed the health impacts.
Well, from one bad invention to another.
Oh, boy.
Let's talk about Freon. Before Freon, refrigerants were really dangerous.
Really?
Imagine your fridge leaking gas that could kill you.
Yikes.
They really needed a safer option.
So that's where Midgley comes in.
Yep.
He looked at fluorine compounds, came up with dichlorofluoromethane.
Try saying that 3 times fast.
Uh-huh, right?
That's Freon.
It seemed like a miracle.
Yeah.
Not toxic, not flammable, and stable.
Not like the other dangerous option.
Right.
And just like with the leaded gasoline, there's a big demonstration.
What did he do?
Inhales Freon and blows out a candle to prove how safe it is. Wow. It was like a PR stunt.
That made everyone think Freon was this amazing, harmless chemical.
Totally.
So they used it in fridges and air conditioners,
Mm-hmm.
and then aerosol cans too.
It was everywhere.
And it seemed perfect.
Until decades later, scientists find out CFCs like Freon
Huh.
are eating away at the ozone layer.
The thing that protects us from UV radiation.
Talk about unintended consequences.
Wow. And here's the thing. These CFC molecules, they're like super stable down here on Earth. But up in the atmosphere, where the UV radiation is intense, they become super reactive.
Oh, wow.
And that's what causes the ozone to break down.
So nobody could have predicted that back then.
Nope.
It's scary to think that something that seems so harmless
Right.
could have such a massive effect, not just in one place, but like globally.
Yeah, the ozone layer.
Thing that protects us from harmful UV rays.
Imagine, spending time outside without it. It would be so dangerous.
Yeah, everyday activities would be risky.
Absolutely. It was a wake-up call for everyone.
So what happened? Did they just, ignore it?
Thankfully, no. The world came together and made the Montreal Protocol back in 1987. They agreed to phase out CFC production.
That's good.
It's considered one of the most successful environmental agreements ever.
That's awesome.
But, the ozone layer is still healing.
Oh, really?
It's going to take, 40 years to fully recover.
That's a long time.
It is.
It really highlights the lasting effects of these inventions.
It's like a ripple effect that just keeps going.
Spreading out further than anyone could have imagined.
Exactly.
It makes you think about how responsible we need to be.
With new inventions, yeah.
Sadly, though, Midgley didn't get to see the full extent of the damage.
No, he died in 1944.
Oh, how'd that happen?
Well, he got polio.
Oh, wow.
And he designed this system of ropes and pulleys to help him get out of bed.
Okay.
Tragically, he got tangled up in it.
Oh, no.
And accidentally strangled himself.
Wow, what a way to go.
I know, right?
The man who gave us leaded gas and Freon, killed by his own invention.
It's almost ironic.
Yeah, it's kind of like a Greek tragedy or something.
Right.
But seriously, what can we learn from all this?
That's the question, isn't it?
Was Midgley a villain? Or just a product of his time?
It's complicated. He did solve problems like engine knock and those dangerous refrigerants.
Right.
But those solutions created global problems that we're still dealing with.
It's like innovation can be a double-edged sword.
Exactly.
You mentioned earlier that he often chose the profitable solution over the safe one. Do you think he knew about the dangers?
It's tough to say. But, his inventions were supported by big corporations.
Right.
General Motors, DuPont, Standard Oil.
Those are some powerful companies.
They had the resources to make and sell these products on a huge scale.
And to downplay the risks?
Even suppress evidence.
So maybe Midgley was a victim of the system in a way.
It's possible.
Caught up in this whole progress and profit machine.
Yeah.
They didn't really think about the long-term consequences.
That's a good point.
I mean, regardless of whether Midgley was to blame or not,
Yeah.
his story shows us a bigger problem.
What's that?
The relationship between science, industry, government, and the public.
Oh, I see what you mean.
We can't just blame one guy.
Right.
We need to understand the whole system.
That allowed these products to become so widespread.
Exactly. It's about accountability on multiple levels.
I agree.
But it makes you wonder, could this happen again?
That's a scary thought.
Are we doing enough now to prevent future Midgleys?
From unknowingly causing harm.
Especially with all the new technology we have.
It's the million-dollar question.
So what can we learn from all this?
Well, the sources we've looked at suggest a few key things.
Okay, like what?
We need solid science that's independent of corporate influence.
So companies shouldn't control the research.
Right. We can't let money dictate what gets studied or how the results are interpreted.
That's how we got into this mess in the first place.
Exactly.
What else?
We need regulations that put people and the environment first.
Like stronger environmental protections.
Yeah. The delay in regulating leaded gasoline, even with all the evidence.
It shows how costly inaction can be.
Exactly.
Is there anything else?
I think the most important thing is a change in mindset.
Oh, how so?
We need to stop thinking short term.
Okay.
And start thinking long term.
A more holistic approach.
Yes. We need to ask ourselves, what are the potential consequences
of new technology?
Right. What are the unintended effects that we might not be able to see right now?
It's about looking beyond the immediate benefits.
And considering the bigger picture.
But how can we predict those unintended consequences?
Especially with technology advancing so quickly.
Yeah, it seems almost impossible.
That's where things get even more interesting.
Oh, how so?
Midgley's inventions needed huge factories and systems to reach the whole world.
Okay.
But imagine a technology that can copy itself.
Copy itself.
Yes, spreading really fast.
Yeah.
And potentially causing harm on an even bigger scale.
It sounds dangerous.
It is.
This is where the lessons from Midgley's story become even more important.
Absolutely.
Are you talking about things like gene editing and nanotechnology?
Exactly. Those are self-replicating technologies.
I've heard they can be amazing, but also pretty scary.
They have incredible potential, but the risks are huge, and often we can't predict them.
Can you give me an example?
Sure, think about CRISPR, the gene editing tool.
Yep.
It could cure genetic diseases, improve crops, even get rid of malaria-carrying mosquitoes.
That sounds great.
But what if a gene drive accidentally changes entire ecosystems?
That's terrifying.
It is!
It's like those sci-fi movies where nanobots escape and take over everything.
Well, it's not just sci-fi.
Yeah.
With nanotechnology, we can manipulate matter at the atomic level.
Wow.
It could revolutionize everything from manufacturing to medicine.
Does sound revolutionary.
But what if self-replicating nanobots get out of control and disrupt ecosystems in ways we can't imagine?
So these risks are even bigger than what we saw with leaded gas and Freon.
They are definitely in a different league.
So what can we do?
The challenge is not to stop innovation.
But to make it safer.
Yes, we need safeguards, ethical guidelines, and risk assessments.
That work for these new technologies.
Exactly. We need to learn from Midgley's mistakes.
Yeah.
It really is a lot to think about.
We're like standing at the edge of a whole new world of scientific progress.
And it's moving so fast.
So how do we even begin to understand these risks?
Well, it is, it's daunting. There's no doubt about that.
Yeah.
But it's not impossible. We need to take a multifaceted approach.
Okay.
One that involves scientists, policymakers, ethicists, and the public all working together.
So collaboration is key.
Absolutely. And we need to invest in what's called foresight research.
Foresight research. What's that?
It's basically exploring all those potential future scenarios.
Okay.
And trying to identify those risks, early on.
So it's kind of like a pre-mortem for new technologies.
Exactly. Thinking about what could go wrong.
Before it actually does.
Right, exactly.
That makes sense.
And we also need to create regulations, regulatory frameworks that can keep up with how fast technology is changing.
Yeah, because the old ways of regulating,
Yeah, they're just not going to cut it.
they usually only react after something bad has already happened.
Right, and that's not good enough for these self-replicating technologies.
We need to be more proactive.
Exactly.
So it's not about saying no to every new invention.
Right. It's about finding a way to encourage responsible innovation.
From the very beginning.
From the start, we need to find ways to build in those ethical considerations right from the get-go.
Yeah, that makes sense.
Think about, ethical review boards
Okay.
for new technologies, similar to what we already have for research involving humans.
Oh, I see. So it's kind of like a checks and balances system.
Exactly. It's about making sure that we're thinking about the ethical implications
Right from the start.
before things get out of hand.
And what about the public?
Oh, public education is absolutely crucial.
Yeah, people need to understand these technologies.
Absolutely. They need to be able to weigh the risks and benefits.
So they can make informed decisions.
Yes, and participate in these important conversations.
Because these decisions affect all of us.
They do. We need to move beyond all the hype and fear-mongering that often surrounds these new technologies.
Yeah, it's easy to get caught up in all that.
It is, and instead we need to engage in open and honest conversations.
About the potential impact.
And that requires clear communication from scientists, policymakers, the media.
It's about making this information accessible to everyone.
Exactly.
This whole deep dive into Thomas Midgley Jr.'s inventions has really been,
eye-opening.
yeah, eye-opening. He was a brilliant guy, He solved some real problems.
But his legacy,
It's kind of overshadowed by those unintended consequences.
it really highlights the importance of thinking ahead.
Considering those long-term effects.
And not being complacent when it comes to innovation.
Right. We can't just assume everything will be okay.
We need to be asking those tough questions, the what-if questions.
What if this goes wrong? What if that happens?
Exactly. And then we need to invest in the research and the safeguards that can help us prevent those problems.
So it's all about finding that balance, right?
A balance between the excitement of new discoveries.
And being cautious about the potential downsides.
Exactly.
At the end of the day, it's about responsibility.
Accountability.
Making sure that scientific progress benefits everyone.
Without harming our planet.
That's a great point.
It's a challenge, but it's also an amazing opportunity.
To shape the future.
We're at a crossroads.
And the choices we make today will have a huge impact on the world of tomorrow.
We need to make those choices wisely.
Well said. Well, folks, that wraps up our deep dive into the life and legacy of Thomas Midgley Jr. We've explored the complexities of invention, the unintended consequences, and how science, technology, and society are all intertwined.
It's been quite a journey.
It has, and we hope you found it as thought-provoking as we have.
We've learned a lot.
Until next time, keep those brains buzzing. Remember, the future is in our hands.